Hello, everybody. So in this video, I'm going to be discussing project assignment number 3, which is on correlation and regression. So let me go ahead and share my screen and we'll get started. So as with all the project assignments, you're going to do your work on this template here. There's a sample here of one that I did with my data set, and then the video which you're obviously watching, and then the rubric that you can look at to see how you're going to be graded. So I'm going to go ahead and open up my sample here, and I'll go through that. Let me go ahead and stop my share and switch over there. All right, so in this assignment, you're going to explore your two quantitative variables from project assignment 1, and you're going to see if they're related. So you're going to create a scatter plot with the linear regression line and find the correlation coefficient and linear regression equation using our guru, and then you're going to do a little bit of analysis with it. So this is all just kind of general instructions. As with all project assignments, if you get everything looks good on the first attempt, you'll get 100% from the start. Otherwise, you'll get 50% until you make revisions, and then you'll be graded either if you got it all correct the second time, you get 100%, 70% if you did most of it correct, and if you did less than 50% of it correct, 50%, and of course 0 if you don't submit anything. But if you make all the corrections, you should be getting 100% hopefully on the second attempt. And if you want to see what constitutes each of those grades, you can look at the rubric. And you have 7 days once you receive my feedback to resubmit the second attempt of the assignment. So first of all, let's talk about, so you need to first identify which of the two variables is the explanatory variable and which one is the response variable. So I'm actually going to open up my project assignment 1 here just to show you where I'm getting these two variables from. All right, so in project assignment 1, I had two quantitative variables I used, years of service and salary. So the question becomes, so the explanatory variables like the x variable, the response variables like the y variable. So the x variable should impact the y variable. So does years of service impact salary, or does salary impact years of service? So years of service would impact salary. That's the direction that makes sense. So my explanatory variable is going to be years of service, and my response variable is going to be salary. Make sure you use the two quantitative variables that you used in project assignment 1. And remember, you're using the same data set the whole semester. So when you're thinking about this here, and for some of you it may not matter, but a lot of times there's a direction that makes more sense. So think about the explanatory variable has to impact the response variable, not the other way around. Okay, so now I'm going to show you how to do all the scatter plot and the correlation coefficient and the least squares line in our guru. Let me go ahead and stop my share. Go to our guru here. So you're going to go to our plots, create plot, and scatter plot. You're going to select your data set. So mine was salaries. My predictor or my x variable, that's my explanatory variable. That was years of service. My response variable or my y variable was salary. Then check LS line and show correlation in LS equation. And then hit the eyeball. Now you can right click and copy this image for this scatter plot. You can also like screenshot it, but you're gonna have to take a screenshot of what's up here. So you're gonna kind of have to take probably 2 pictures, or you could take probably one big screenshot depending on your computer. And then you'll put that into the document. And then if you wanted to save it, you could put the title here and save it if you wanted to. All right, so let me now go back to the assignment. So you can see I have the correlation coefficient on the least squares line here, and then the scatter plot here. So now I want the correlation coefficient. So that was given to us here. That was the R equals 0.33474. And then I want us to interpret that. So is the correlation strong, moderate, or weak? And is it positive or negative? So there's a chart from the chapter 12 notes that we can refer to for this. So I'm going to actually pull that up here. So it's a little farther down here. Here's the chart. So you can see where your correlation coefficient falls in this chart, and that'll give you the interpretation. So mine was 0.33474, so that falls in here. So that gave me a weak positive relationship. So that's where I got my answer for that. So you need to pull up the chart from the chapter 12 notes to answer that. All right, and now I want the linear regression equation in y equals mx plus b form. So up here, we have the linear regression equation. Remember, salary was y, years of service was x. So this is the same as y equals 99,975 plus 779.57 times x. So the only thing you have to do is you just have to flip the x term and the constant to make it in y equals mx plus b form. So I wrote it as y, or I believe I used y hat. Yep, equals 779.57x plus the 99,975. Just be careful you keep your signs with the correct terms. So if this was negative here, then we need to stay with the x term. So make sure you keep your negatives on the correct terms if you do have negatives. And then choose some value for the explanatory variable and predict the corresponding response variable. So I chose 10 years of service. Pick something that makes sense. So 10 years of service would be logical. Don't pick like 1,000 years, for example. So plug it into the equation, evaluate, and then give me your prediction. And then I want to know after that, is it an interpolation or extrapolation? So an interpolation means that the x value plugged in is within the range of the x values in the data set. So mine was 0 to 60. So since I plugged in 10, that's an interpolation. If I plugged in 70, that's outside of the range of the x values in the data set, that would be extrapolation. So it's all about whether your x value falls within the range of the x values in the data set that you plug in. And then the final step, we're going to write a 1 to 2 paragraph description of the graph, correlation, coefficient, and equations. What does there seem to be a correlation? What does this suggest about the variables for the population? Would it provide reasonable, reliable predictions, and who might be interested in the predictions? So I'll just kind of talk about what I wrote here. So first, kind of talk about what you see about the relationship between the variables. Does there seem to be a correlation? So based on the scatter plot and correlation coefficient, I have a weak positive relationship between my two variables. So that means although more user service sometimes does result in more salary, that's not necessarily a strong and reliable relationship because the relationship's pretty weak. So I can't always say more user service is going to lead to higher salary. And so that kind of covers the first two questions, talking about whether there's a correlation and what does this then suggest about the variables in the population. And then talk about would it provide reasonable and reliable predictions. So since I didn't have a strong relationship, my regression equation will not provide reasonable and reliable predictions. They don't prove to be super useful and may not be super accurate because the relationship's weak. If your relationship was strong, you could rely on your predictions. So it's all about whether you have a strong relationship or not. And then go into talking about who might be interested in the prediction. So in my scenario, I said researchers may be investigating how years of experience impact salary, and also college professors who are looking to predict how their salary is going to increase as they get more years of experience. Those could be potential uses for these predictions. And I also just added at the end that any interpretations from this specific linear regression equation should be interpreted cautiously because I only have a weak positive relationship. If I had a strong positive relationship, it would give me much more reliable predictions, and I'd be able to rely on the relationship between the variables and know that more years of service would correspond to more salary. But that's not my case here since I had a weak relationship. So you can kind of look at mine as kind of like a model to help you out. Just make sure that you cover all the questions. And that is it. So that is project assignment 3, correlation and regression. If you have any questions, please feel free to reach out.